Okay, number one on our study guide, Donna deposited $22,000 in an account that pays 8% compounded annually. So when we see compounded annually, we know the final amount is equal to the initial amount of principal times 1 plus the interest rate as a decimal to the number of years power. So we're looking for those three values, the principal, how much money is invested, so in this case $22,000. And we're looking for the interest rate as a decimal, so it's 8%, so it's 0.08. Be very careful, it's 0.08, not 0.8. And then n equals 6 years. I'm using t, they used n, but it's the same formula regardless. So basically to get the answer, I'm going to do 22,000 times, and I can do 1 plus r in my head. 1 plus 0.08 is 1.08 to the 6th power. So that's how I'm going to find the answer. My calculator over here, type in 22,000 times 1.08 caret 6 equals. We end up with $34,911.24. How much money should have after 6 years. It says, what was the total interest earned? Okay, so be careful now that A sub t is not interest earned, it's how much money she has in the account. So this is the final amount of money. To get interest, we have to subtract the initial investment. So if we subtract 22,000 from this, you can see she got $12,911.24 in interest. So do be careful that the formula here gives us how much money is in the account, but it includes this money we started off with. So we do subtract the initial investment to find out the interest earned. If it said how much money was in the account, we would have stopped here. So just make sure you pay attention to what they're asking for. Number two, for a meshed gear of fixed radius, the number of revolutions per minute varies inversely as the number of gear teeth. So revolutions per minute varies inversely as teeth. So I'm going to go with RPM equals K divided by teeth. Inversely means K divided by, directly would be K times. If a particular gear had 120 teeth, it would revolve at 25 revolutions per minute. So this is the revolutions per minute. This is the number of teeth. So this is R, this is T for this structure. So 25 over 1 is equal to K, we don't know yet, over 120. And I do recommend putting whatever this is over 1 just to create a proportion. If I cross multiply, K times 1 is K, and 25 times 120 is, I believe, 3,000. Yep, 3,000. So let's know what K is equal to. That goes right back up here. So the original structure was R over 1 is equal to K over T. Keeping R and T what they are, K is going to change to 3,000. So now it says what RPM would result. So what RPM would result means we don't know what R is if the teeth were reduced to 30. So we're ending up with 30 teeth. So R should equal 3,000 over 30. 300 divided by 3 is equal to 100 RPM. So inverse variation, use the statement along with given information to find K. Use the constant along with given information to find what they're asking for. Number 3, Hannibal rode the elephant to the outskirts of Rome at 5 kilometers per hour and then took a chariot back to camp at 14 kilometers per hour. So what we can see is Hannibal is somewhere at camp, I guess, and he rides his elephant somewhere and ends up there. So he goes there. Then that's on an elephant, and you might put D sub E if you want elephant as your category. Then he goes back on a chariot. He goes back the way he came, so he goes the same distance. So the distance going there and the distance on the chariot are the same, and I'm going to call this E for elephant. So his distance on an elephant equals distance on chariot. So I'll make my categories elephant and chariot. What we know about rate, because once we figured out the distance expression equation, I want to figure out these 4 things. He rode the elephant at 5 kilometers per hour, kph. Means time is in hours and distance is in kilometers. Getting the right units on these things. He's riding back at 14 kilometers per hour in a chariot. The total trip took 38 hours. So neither one of the times was 38, but this took t hours of it. 38 minus t was left over. Or this took t hours, 38 minus t is left over. Doesn't matter which one's which, just wherever you put it. If where I got it set up, t is going to represent the elephant's time. If you put t down here, t would represent the chariot time. So just, that's the only matters. That's the only way that matters. Once you get the rates and times filled in with at most one variable, you multiply rate times time to get distance. 5 times t is 5t. 14 times 38 is 532 minus 14t. Make sure that this is a binomial here, so we distribute 14 times 38 and 14 times t. Distance elephant equals distance chariot. So 5t is equal to 532 minus 14t. 14t moves to the left, you get 19t is equal to 532. Divide both sides by 19. It comes out to 28. T is the time on the elephant, so 28 hours is what that is. And the question asks us, very specifically here, how far was it from camp to the outskirts of Rome? In other words, how far, here's camp to the outskirts of Rome. They're asking for the elephant's distance. So, they're asking me to find out what this is. All I found out was t is. So to find the answer they're asking me for, I then have to take the 28 hours times the 5 kilometers per hour. So 28 times 5, 140 kilometers is what they're asking me to get. So make sure you answer the question. This is not always the answer to the question. So that's what t is. You can use t to find what we're looking for. Number 4, we have a radical in the denominator, which is not good math, so we want to fix that by getting this radical to become an integer. I do that by multiplying by the exact same thing on the top and bottom. So if I multiply the square root of 3 times itself, I'm going to get 3 on the bottom. If I multiply the bottom by anything, I'm going to multiply the top by the same thing. The top is a binomial, so a distributive property is required to do the multiplication there. So if I distribute, I'm going to bring all this stuff down so I can draw some arrows. If I multiply the square root of 3 times this and the square root of 3 times this, that's going to get the top simplified. So 6 times the square root of 3 makes 6 times the square root of 3. They're different kinds of objects. You stick them together. Positive 5 squared 11 times positive square root of 3. First of all makes a positive. 5 times 1 makes 5 outside. 11 times 3 makes 33 inside. Then on the bottom, square root of 3 times the square root of 3 just makes 3. No more radical. Now, that's it, the end. And some people are tempted, they see 3, 33, and 3, they start thinking maybe I can reduce. But this 3 is outside, these 3's are inside, so you can't reduce. Don't expect it to reduce. Just once you get that done, stop there. Number 5, same type of problem, a little bit simpler, really, once you get it fixed. Square root of a fraction can be separated into the square root of the top over the square root of the bottom. So that's the first thing you want to do. And again, the issue here is good mathematics says radicals in the denominator is not good. So we want to multiply by the square root of 13 to fix the bottom. If I multiply the bottom by the square root of 13, I've got to multiply the top by the square root of 13. So on top, I multiply one thing times one thing, but they're both inside radicals. So inside a square root symbol, I just multiply 13 times 5, I get 65. And then square root of 13 times itself is just 13. The end. That's as much as we can do to that. That's the correct answer. Number 6, I want to graph the inequality on a coordinate system, and it's a linear inequality. So first thing I want to do is pretend there's no inequality system. I'm going to just pretend I'm graphing y equals 1/3 x plus 1. Plus 1 is the constant, and that's the y-intercept. And a slope of 1/3 tells me from this point that's on the line, I'm going to go up 1 space and right 3 spaces to get another point. Or from that point I can go down 1 space and left 3 spaces to get another point. To get several points on the line. Then I want to connect those dots with either a dashed line or a solid line. So, looking at this inequality, it's greater than, not equal to. Not equal to means we use a dashed line to connect the dots. So, it would look like so. Once we get our boundary line graphed correctly, what's left to do then is to shade the correct region. I'm going to call this region A and this region B. It doesn't matter which one's which. Whatever you call is fine. If you call this region A and region A is supposed to be graphed, then you're going to get region A. If you call it region B, then you get region B. So whatever you call them doesn't matter. And you want to pick a test point being a point not on the line. So any point, there's billions of points there to pick from. Not just these, but I could pick like right there, or right here if I really felt like it, if I wanted to create a more difficult problem. If we just stick to the integer value points, 0, 0, if it's available, is really easy to use. Okay, it's really simple. The test point goes like this. 0, 0 means specifically that x equals 0, y equals 0. That's what that point means. And if I take x equals 0, y equals 0 into that original inequality and just put them in there, see what happens. So if y equals 0, I'm going to get a 0 there, is greater than. X equals 0, that makes 0 plus 1 makes 1. It creates a statement that's not open to interpretation. It's either true or false. 0 is greater than 1 is a false statement. So what you have to ask yourself is, which region does 0, 0 lie in? If you look, for my picture, region B is where 0, 0 lies. 0, 0 is false, which means every point in region B is going to be false, which means that region A is the truth, and we want to always shade the truth. So you simply shade towards the truth every time. Had I picked another point, let's say I picked this point here, 2, 3. And I put that into this. Y is equal to 3. 2 times 1/3 is 2/3 plus 1 is 1 2/3. 3 greater than 1 2/3 is true. But notice the test point lives in region A, which still means shade region A. So whether you get true or false, you can figure out what the truth is. Just shade the truth every time. Number 7, sketching a graph. First thing I want to do is consider the parent graph. So let's just say P of x is the parent graph. I see something squared, so the parent graph is x squared. And our chart for x squared is -2, -1, 0, 1, 2. We square everything. Everything squared, whether it's negative or positive, is positive. So positive 4, positive 1, 0, positive 1, positive 4. So my parent graph, -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. Don't connect the dots in the parent graph. We just need those dots to help us graph the actual graph. Now, if we look at graph G, I'm going to do this in green. There's two things happening in graph G. We've got a number being subtracted from x inside the parentheses. That's going to move us to the right 3 spaces. We have a number being subtracted from G, from the x squared object. That's going to move us down 4. Inside the parentheses, horizontal movement opposite of the sign. So horizontally 3 spaces, sign's negative, so we go opposite, which would be right. Number outside the parentheses is a vertical movement, the direction you expect. Negative goes down, positive goes up. Every one of these points I want to go 3 spaces right and 4 spaces down to get a new point. So that point became this point. 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. And 1, 2, 3, 1, 2, 3, 4. Every one of these points moved 3 spaces right and 4 spaces down, creating for us the correct graph of G. So again, go ahead and put the dots for the parent graph on there. Use those to interpret the dots for G, but just graph G when you're actually graphing it. That'd be a little bit easier for you to grade, I think, than to look at the parent and the graph on the same thing. But just to kind of take a look at this real quick, here's my original. I'm just going to take this and I'm going to slide it 1, 2, 3 left, or right, and then 1, 2, 3, 4 down, and you can see that it ends up where it's supposed to. So every one of those points moved correctly. Inside the parentheses, opposite horizontal movement. Outside, exactly what you expect, vertical movement. Both movements have to be accounted for. Number 8, sketch the graph of 3 to the x power. So what I told you to do on this is to pick these three exponents, -1, 0, and 1. Reciprocator equals 1 equals the base. So 3 is the base, -1 makes a reciprocal, so we get 1/3, better known as 0.33. Anything the 0 power is equal to 1, anything the first power equals itself. So whatever the base is, reciprocal of base, it doesn't matter what it is, it'll equal 1, and whatever it is, it is. Okay, so you get those 3 points. -1.33 would be about here, kind of estimate its position. 0, 1, and 1, 3. That connects to make this. One of the sides flattens out, the other side goes up to infinity. So this side's going up to infinity, this side's flattening out. Be careful that wherever the 1 is, it's never going to go beyond the next bar. So it's going to flatten out this way, kind of right along the x-axis there. And we're supposed to put a horizontal asymptote where the graph is not going to cross. Make sure you put that in there. Also, the x-axis itself is the horizontal asymptote. So far, that's all we've gotten for an asymptote. So expect, if it's just a number to a power, that x-axis is going to be imagine the most powerful electric fence in the world. The graph's not going to want to cross it. So it's going to get close to it but not touch it. So make sure, I've seen people at this stage of the game, they'll just they'll draw their 3 points. You move this out. Oh, tell you what. Move this out of the way. So I've seen people draw their 3 points and not worry about an asymptote, just do something like that. That's just not good. So again, the graph looks like I had it initially. Put it all back together. It looks like that. So it's going to have that bend to it. The part that's going up is going to go pretty much straight up. The part that's coming down is going to flatten out and make sure it doesn't cross that x-axis. Number 9, find the equation line that's parallel to this, and it passes through that. Let me give you guys a different way of doing this that you might prefer than what I've shown you before. Basically, it's going to be the same thing. It's just going to be a different look at it. If lines are parallel, they have the same slope. So by giving me the equation in this structure, y equals 2/3 x plus 3, I know that the answer I'm looking for is going to look exactly like this, and this is going to be different. So what I can do as soon as I see it's parallel to y equals 2/3 x plus 3, I can say my answer is going to be y equals 2/3 x plus unknown. And I usually call that unknown b. All right, so I immediately, if I just know it's parallel, it's going to look like this. Then, the point that my line's passing through, x equals 6 and y equals 1, I'm just going to replace x and y with those two numbers to figure out the value of b. So I'm going to put 1 in for y, 2/3 is going to stay 2/3, being multiplied by x, which I'm replacing with 6, plus b. Now I just need to solve this equation. 2/3 times 6, 6 divided by 3 is 2, times 2 is 4. Move the 4 to the other side, we get negative 3 is equal to b. So just like that, here's the structure of my answer. I'm going to change b to what b equals. So I'm going to end up with y equals 2/3 x minus 3. I do expect to see an answer looking like this. Don't just put b equals negative 3. Actually write the equation line. That's the structure. This needs to be replaced with b's value to get the correct answer. All right, number 10. Find the equation line whose slope is 5 that passes to the point 2, negative 3. So if I kind of equate this to what we just did in the last problem, the slope is 5, they tell us that. And we know y equals mx plus b is our structure. So if I use that fact, and we know the slope is equal to 5, that means I know the structure of my answer is going to be y equals 5x plus b. So it's pretty much like the last problem was. I know that y is equal to negative 3. I know x is equal to 2 in the point they give me, so I just start off right there because I know what the slope is. Substitute what I know in, negative 3 for y, equals 5 times x, which is positive 2, plus b. That leaves me with this structure, again, b being the only value that we don't know. 5 times 2 is equal to positive 10, moves over here as a negative 10. So negative 13 is equal to b. And just like that, slope is 5, y-intercept negative 13. This is the structure of the correct answer. I'm going to replace b with what b equals. So I end up with y equals 5x minus 13 as my final answer. Always write, it says find the equation line, make sure it's the equation line. A lot of people forget the x. Don't forget the x. It doesn't make a proper equation if the x isn't there. Okay, I'm wearing a different shirt because I had to start the video a different day because I had some issues with my computer yesterday. Multiply 3 plus 4 times the square root of 5 times 2 minus 3 times the square root of 5. We're going to FOIL this, so first times first, 3 times 2 makes 6. 3 times negative 3 square root of 5, a positive times negative makes a negative, 3 times 3 makes 9, and then the square root of 5 comes along for the ride. Maybe 5 is 6. And then 4 times the square root of 5 times 2, they're both positive, so you get a positive. 4 times 2 makes 8, then you get a square root of 5, it just comes along. And then 4 square root of 5 times negative 3 square root of 5, positive times negative makes a negative. 4 times 3 makes 12, and the square root of 5 times itself makes 5. So when you multiply these two radicals, you get a whole number out. At this point, the non-radical pieces are going to be able to add together. This makes a total of negative 60. So we have 6 minus 60 makes negative 54. And then the square roots of 5 can add together by adding the front numbers. Negative 9 plus 8 makes negative 1 times the square root of 5. The 1 is optional. If you put minus the square root of 5, it means the same thing. Take your pick on how you want to write that. Number 12, solve the square root of x minus 5 minus 1 equals 4. Our first task is to get the square root object isolated. So this is the square root object. The minus 1 needs to move to the other side. So I'm going to get the square root of x minus 5 alone by itself on the left-hand side. This becomes plus 1 over here, so I get equals 5. Then I got to square both sides. So I'm going to get x minus 5 without the radical must equal 25. Then I simply solve that by moving the 5 to the other side, change the sign, so we get x is equal to 30. That represents what can be the right answer. We again have to verify with these kind of problems every time. So I'm going to change x into 30, so that's going to become the square root of 30 minus 5 minus 1 is supposed to equal 4. Square root of 30 minus 5, that's the square root of 25. Square root of 25 is 5. I see a true statement there, so I can verify that 30 is the correct answer. Number 13, we're supposed to factor this. The first thing I notice is that the x term and the constant are in the wrong order, so I'm going to rearrange it. So 4x squared is going to stay right where it's at. I'm going to put minus 16x in the middle and then plus 15 last. And since we have a number in front of x squared, there's no way to reduce by 4 because 15 doesn't divide by 4, so there's no common factor issue here. I've got to multiply these two guys together to figure out the factors of number. So we want factors of positive 60x squared. We want the sum of those factors to be negative 16x. So if I start thinking through factors of 60 that would add up to make 16, that's going to be 6x and 10x. But since it's negative 16, I want it to be negative 6x and negative 10x. Two negatives make a positive, and two negatives added together make a negative 16x. So this is the correct pair of numbers. So I'm going to replace this guy here with these two numbers. So the problem then transforms itself into 4x squared, which stays the same. This breaks apart into minus 6x minus 10x, and then this stays the same. Usually we like to get the third position positive, but with both of these being negative, we don't have that option this time. So it doesn't matter if I put minus 6x minus 10x or minus 10x minus 6x, whichever order you put it, it'll work. If I start grouping though, it's very important that what I get grouped has to be the same as the original expression. With a minus in the third slot, we need to put a minus in between the parentheses. The minus distributes through, so minus a 10x makes minus 10x. Minus a minus 15 makes the positive 15. So this sign right here becomes its opposite. So that's the one extra issue here that happens because of the fact the third position object has to be negative. If I look at the first group, I'm going to underline it in red, looking for a common factor. Oh, and you know what? That says 4x squared. This should say 4x squared. This should say 4x squared. Looking at 4x squared and 6x, the common factor is going to be 2x. 2 divides both numbers evenly. Both numbers contain an x, at least to the first power. And if I take 2x out, I'm going to be left with 2x for the first object and minus 3 for the second object. The second group has a minus in front of it, so I can continue to have a minus in front of it. Looking at the numbers in the group of 10x and 15 both divided by 5. If I take a 5 out, I get 2x minus 3 left over. And what should happen when you do this correctly is that this group and this group should be the same thing, which they are. That's one of the factors. And that's going to multiply by whatever these two guys are, including that sign. So parentheses, parentheses, there's a multiplication between the parentheses. 2x minus 5 goes in the second group, and there's our factored form. But again, be sure that you swap the order of those to begin with, and again, that's the technique we've been using to factor these for right now. Number 14, factor by groupings. This is already ready to go, factor by grouping problem. First two group, the second two group, and there's a plus in the middle, so there's no sign issues to deal with there. Looking at the first group, common factor of A, so if I take A out, C plus D is left over. The second group has a common factor of B, so if I take B out, C plus D is left over. First group, second group, and the common factor, C plus D, for the whole thing, and we're left with A plus B for the other part. And 15, find the surface area of the sphere. We look at our formula sheet, or hopefully in our memory. The surface area formula for a sphere is 4 pi times the radius squared. So all I have to do is 4 is 4, pi is 3.14, and the radius squared, the radius is 10 inches, square that, you get 100. So then we just have to do 4 times 3.14, which is 12.56 times 100. And 12.56 times 100 is 1,256. Unit of length is inches, area is in inches squared then. So 1,256 square inches. I'm going to ask for the surface area of a sphere on the test. It'll give a different radius. So just apply the formula. Square the radius first, multiply by 4 times 3.14 for each answer.